Hi children! So tonight's homework is actually for you to graph a system of inequalities. So remember, a system of inequality is when you have more than one inequality and you want to find the area of the coordinate plane that makes both of these inequalities true at the same time. So I'm going to be working with two inequalities here. I have 4x minus 5y is greater than or equal to negative 35, and I also have x plus y is greater than negative 2. So neither of these inequalities is solved for y, so I'm going to just solve both of them for y and then use the information I can get from that inequality to graph my two inequalities. So starting with the red inequality, I'm going to write 4x minus 5y. 4x minus 5y is greater than or equal to negative 35. In order to solve for y, I want to get the y term by itself. The y term is negative 5x, so right now I notice what I can do is I can subtract 4x from each side. The 4x minus 4x cancels out. That was the whole reason we did it. I bring down every single other thing. So negative 5y greater than or equal to negative 4x minus 35. The last thing I would need to do in order to solve this for y is divide everything by negative 5. When I do this, my symbol has to flip because I'm dividing by a negative number. So it's no longer greater than or equal to, it's now less than or equal to. I have my negative 5 and negative 5 canceling out, so I get y is less than or equal to, a negative divided by negative is positive, so 4/5 x. And then a negative divided by a negative is a positive, plus 7. So once I get down to my final inequality, solve for y, I can pull out the information I need. I need to know my beginning value is 7, which means my beginning point is 0, 7. I need to know how my graph is moving, which is my slope, 4/5. This lets me know I'm moving up 4 spaces, to the right 5 spaces. And the last thing I need to know is that my symbol is less than or equal to, which is a solid line. So I would use all this information together to graph this inequality. So if we take a look at our graph, I want to graph the point 0, 7. So 0, 7 is here. And then I want to follow my slope up 4/5 spaces. 1, 2, 3. Whoops, there's no 4 spaces that way. So I actually have to go backwards. 1, 2, 3, 4. 1, 2, 3, 4, 5. So here would be my next point. So I'm going to go ahead and put a point there. 1, 2, 3, 4. 1, 2, 3, 4, 5. Right there. Okay. And I would go backwards again. 1, 2, 3, 4, 1, 2, 3, 4, 5. And again, I said this would create a solid line, so now I'm going to connect these points with a solid line as best as I can make. Not too bad. And of course, my final step is to decide which side is true. So I'm going to check the point 0, 0. I'm going to plug in 0 for x and 0 for y and see if it makes my inequality true. So let's go back up to our inequality. My inequality was 4x minus 5y. So I'm going to write 4 times 0 minus 5 times 0. And I want to check if this is greater than or equal to negative 35. So I get 0 minus 0. Well, that's 0. Is 0 greater than or equal to negative 35? Yes, 0 is greater than negative 35. So this is true. So I know that side of my inequality is true. So I know this part is true. So this is the side that I would shade here. Okay, so that's just part of my problem. The next thing I have to do is I need to do all the exact same things for my blue equation. So if we look at our blue equation, my blue equation is x plus y is greater than negative 2. Now to solve this for y, it's much simpler than the last one. I subtract x to each side. That cancels out this x. I bring absolutely everything down. So I'm going to write y is greater than negative x minus 2. And there we go, it's solved for y. I bring out the important information I need to know. My b value is negative 2, which means my beginning point is 0, negative 2. And my slope m is negative 1. Every number is a fraction in disguise, so I know this is negative 1 over 1, which means I go down 1 over 1. That's how my graph moves. And the final piece of information I need to know is that this is greater than, which means this is a dashed line. So I'm going to use all this information to draw this inequality. So I'm going to start by looking at my graph. I want to plot the point 0, negative 2. So I go to 0, negative 2. Right there, and I want to follow my slope, which is down 1 over 1. So it'd be there, and there, and there, and there, and I can keep going down 1 over 1 until I get to the end of my graph. I can even go backwards. I can go up 1, back 1. So up 1, back 1, up 1, back 1, up 1, back 1, and I would keep going. So now they do intersect there, but remember when we have inequalities, our solution is not where they intersect, it's where their areas intersect. So I know this is a dashed line, so I would connect this with the dashed line as best as I can. Okay, and the final part is to check which side is true. I can still check 0, 0 if I want. This means I'm plugging in 0 for x and y and seeing if it makes my inequality true. So if I come back up to my inequality was x plus y is greater than or equal to negative 2. So that means I'm checking if 0 plus 0 is greater than negative 2. Well, is 0 greater than negative 2? Yes, it is. This is true. So if I take a look at my graph again, that means this portion right here where the 0, 0 is true. Which means I'm going to shade this area above this dashed line blue. So I know all of this is blue because this is true. True blue. Okay. Now my solution is the part where both are shaded. So if I look at this graph, the part where both are shaded is this area here. So this is my solution. So I can even mark it as my solution if I wanted. Solution. Okay. You should be able to complete the other 3 problems on your own. If you get stuck, come back and watch this example again. I will see you guys tomorrow.